Welcome back, everyone. I am Saad Salman, your teacher once again. I'm here to teach you, and we'll continue from the types of polynomial functions today. So, without wasting any time, let's start this video. Types of polynomial functions. There are various types of polynomial functions based on the degree of the polynomial. So the most common types are zero polynomial function px is equals to a is equals to ax power 0. Linear polynomial function px is equals to ax plus b. Quadratic polynomial function px is equals to ax squared plus bx plus c. And the cubic polynomial function ax cubed plus bx squared plus cx plus d. So we can see these are related to their names as well. Cubic relates with the cube as a power on ax. So yeah. Now let's go further into detail, and we'll start with the graphs of polynomial function. So the graph of px depends upon its degree. A polynomial having one variable which has the largest exponent is called the degree of the polynomial. So let us look at the px with different degrees. And then the next is zero polynomial function. Degree zero constant function standard form would be px is equals to a is equals to a the x power 0, where a is the constant. Graph. A horizontal line indicates the output of the function which is constant. It doesn't depend on the input. So yeah, this would be the graph. It would be a simple y is equals to 4 line because it's a simple 0 degree, zero polynomial function. So it would have no fancy graphs. It would be just a simple line here where I've written y is equals to 4. Let's continue. Linear polynomial function. So it's a degree 1 linear function. Standard form would be px is equals to ax plus b, where a and b are constant. It forms a straight line. Graph would be a linear function, have one dependent variable and one independent, which are x and y respectively. So in the standard formula for degree 1, a represents the slope of a line. The constant b represents the y-intercept of a line. Giving an example, y is equals to 2x plus 3. We'll see the figure number 2. And here a is equals to 2 and b is equals to 3. So here's the graph. And now we have a slant line y is equals to 2x plus 3 and y-intercept is from 0 to 3 and it passes through a slope of 2. So y is equals to 2x plus 3 and all the constants are linear functions. Now the third one is quadratic polynomial function. So degree 2 quadratic function. Standard form would be px is equals to ax squared plus bx plus c, where a, b, and c are constants. Graph. A parabola is a curve with one extreme point called the vertex. A parabola is a mirror symmetric curve where any point is at equal distance from a fixed point known as the focus. So in the standard form, the constant a represents the wideness of the parabola as a degree. The wideness of the parabola increases. This can be visualized by considering the boundary case when a is equals to 0 and the parabola becomes a straight line. So the constant c represents the y-intercept of the parabola, and the vertex of the parabola would be given by h comma k is equals to minus b over 2a comma minus d over 4a. So there's a difference of 2 here, where d is the discriminant and is equal to b square minus 4ac. Yeah, just said that. Note where the parabola is facing upwards or downwards depends on the nature of a. So yeah, we have discussed it in the last video as well. So when a is greater than 0, the parabola faces upward, and when a is smaller than 0, so the parabola would face downwards. And it's just like the positive and negative signs. If positive, then upward; negative, then downward. We have a graph here. The black graph is of y is equals to x squared plus 2x minus 3, and the blue one is just the opposite of that, minus x squared minus 2x plus 3. So we can see a smaller than 0 is facing downwards, which is blue. It has a y-intercept of c is equals to minus 3, and a greater than 0 is facing upwards with a y-intercept of positive 3. C is equals to 3. Last one is the cubic polynomial function. A cubic equation is an algebraic equation of third degree. So the general form of a cubic function is f of x is equals to ax cubed plus bx squared plus cx 1 power 1 plus d, and the cubic equation has the form of ax cubed plus bx squared plus cx plus d is equals to 0, where a, b, and c are the constant and d is the constant, are the coefficient, and the d is the constant. The coefficient a, b, and c and d are all real numbers, and the variable x takes real numbers, and it makes a which is not equal to 0. In other words, it is both a polynomial function of a degree 3 and a real number. So here's a graph of cubic function. Sorry, this I don't know why it's blur right now, but yeah, this is the graph more or less similar. So we can put this equation ax cubed um, and get the graph in Desmos. And now we have a new topic or a new um, topic here, factoring the polynomial. So key terms would be dividing the polynomial. Division operation of two numbers are as follows. So 14 over 3, it's one type, and we can also write it like this: 4 plus 2 over 3. So 14 over 3, 14 is the dividend and 3 is the divisor. Or in the second example, 4 plus 2 over 3, 4 is the quotient, 2 is the remainder, and 3 is the divisor. And so 14 is equals to 3 into 4 plus 2, just like in the second one with red, green, and blue colors. 14 is equals to 3 into 4 plus 2. So dividend is equals to divisor multiplied by quotient plus remainder. And on the other hand, we have a simple um, formula which can tell us, which describes it. Divisor is outside, dividend is inside, quotient is above the divisor, and dividend and the remainder is in the very end. And we have an example for this: dividing polynomial by long division. So the method of the long division used for the numbers can be applied to the division of polynomial function. So let's start by looking at the method for numbers. For example, we can divide 5482 by 15. By this tells us that 15 divides into 5482 365 times, leaving a remainder of 7. So 15 is the divisor, and the 5482 is inside, and the quotient is 365, and the remainder would be 7. So we could write it like this: 5482, which is the dividend, divided by 15 divisor, is equals to 365, which was the quotient, and the remainder was 7. Or we can just simply write it like this: 5482 is equals to 15 multiplied by 365 plus 7. Yeah. Now we have these binomial theorems, which will be given to us in the exam, but yeah, I've just written them for the practice. Now we'll study a fairly easy topic, and it's a new topic. These are inequalities. So today we'll study non linear inequalities, and just after that I'll show you non-linear inequalities. So linear inequality, an inequality links two or more expressions with the symbol greater, smaller, or greater than, equal to, or smaller than equal to. Inequalities are linear if the expression they contain can be written in the form ax plus b, where a and b are constants. For example, 3x plus 2 is greater than 5. So 3x is a, 2 is b, and greater than 5. Solving this inequality involves finding the values of x that make the inequality true. So in this example, the inequality is true when x is greater than 1. So the solution can be illustrated using a number line as follows. Yeah, this would be a number line. Let's move on next slide. Types of inequalities would be: conditional inequality are those which are true for some but not all the values of the variable. absolute inequalities are those which are true for all values of the variable. So the inequality x plus 1 greater than 0 is true for all the values of x greater than negative 1. Hence, the solution of the inequality is written as x negative 1. This is called the conditional inequality. So the inequality x squared plus 1 is greater than 0 is true for all the values of x. This is called the absolute inequality. Solving the combined linear inequalities. Some combined inequalities contain variables in more than one part. For example, x minus 2 is smaller than equal to 3x plus 2, which is smaller than equal to 2x plus 7. So treat this, so we split them, and it could be easier for us to solve them and then plot them on the number line. So we'll just cut through x minus 2 smaller than equal to 3x plus 2. So we'll just solve it minus 2 great then small than equal to, and then 2x would go would then x would be subtracted from 3x and will make 2x, and plus 2 will remain the same. And then plus 2 will just move back to left side, and it will form minus 4, which is smaller than equal to 2x. And then we can cut those with the table of 2, and minus 2 is smaller than equal to x. And the second part was where we left from 3x plus 2 smaller than equal to 2x plus 7. So in here it's very simple. 3 is subtracted, and x plus 2 would be left, and x plus 2 is smaller than equal to 7, and x would be smaller than equal to 5. All right, now we can write the complete solution as minus 2 smaller than equal to x smaller than equal to 5. So it would be plotted on the number line just like that, and yeah, this would be a solution. Overlapping solutions. Why is this blurry? I don't know. Solve the following inequality and illustrate the solution on a number line. So 2x negative 1 is smaller than equal to x plus 2, which is smaller than 7. So treating as two separate inequalities gives us 2x negative 1 smaller than equal to x plus 2. Now x negative 1 smaller than equal to 2, and then x smaller than equal to 3. And the rest was x plus 2 is smaller than 7. Now just 2 moves to the right side and makes 5 because it's subtracted. And whenever a number is changes its place and its direction, so it changes its sign as well. Just giving an example of x plus 2 smaller than 7, 2 moved from left to right, so its sign changed from positive to negative. So 7 negative 2, it makes a 5, and the big sign of the big number. So x is great smaller than 5. If x is smaller than 5, then it is also great smaller than equal to 3. So the whole solution set is therefore given by x is smaller than 5. This can be seen on the number line. So now we have different graphs for inequality, solving linear inequality graphically. So we can put this in Desmos and find its solution because we are allowed to use graphing calculator, not Desmos, Desmos for our practice, but we can put this in our graphing calculators as graphing calculators are allowed to us in the exam in certain parts. So next is linear inequality. It's a big question, so hang in there, guys. X squared minus 2x minus 8 is greater than equal to 0. So I just wrote it down in step by step so that it is easier for all of us to understand it. And so step 1 would be write the polynomial in the correct form. So the polynomial must be written in the descending order and must be less than or greater than, less than or equal to, or greater than equal to, or equal to 0. So I know it's a bit complicated, but it will be easier if we do more practice of this. And so there's an example on the right side, x squared minus 2x minus 8 greater than greater than equal to 0. So step 2 would be to find the key of the critical values. To find the key critical values, set the equation equal to 0 and solve. So to solve, to get the values of x, we have to put 0 and solve. So x squared minus 2x minus 8 is equals to 0. So we just put them in brackets. X plus 2 and x minus 4, we just factor them, is equals to 0. X is equals to negative 2 or x is equals to 4. So step number 3 would be make a sign analysis chart. To make a sign analysis chart, use the key critical values to find in step 2 to divide the number line into sections. So this sign analysis might seem a bit complicated, but it's very easy. We have all done this in the past in the junior classes. And so we have numbered the number line and we have separated by sign analysis and made a chart of, and made line and -2 and 4. And now we have to perform the sign analysis. To do the sign analysis, pick one number from each of the section, create in step 3, and plug that number into the polynomial to determine the sign of the resulting answer. So in this case, we can choose x is equals to -3, which results in +7, comma x is equals to 0, which results in -8, and x is equals to 5, which results in +7. So yeah, now the step 5 was use the sign analysis chart to determine which section satisfies the inequality. So in this case, we have greater than or equal to 0, so we want all of the positive sections. So step 6 would be use the interval notations to write the final answer. So the answer would be negative infinity, comma -2, join 4, comma infinity, positive 4, positive infinity. We have another example here. It is 2 minus 2 bracket open x plus 4 bracket open x plus 1 bracket close x minus 2 bracket close greater than 0. So the step 1 would be write the polynomial function in the correct form. The polynomial must be written in the form of the descending order and must be less than or greater than or less than or equal to or greater than or equal to 0. So step 2 would be find the key of the critical values, just like we have done in the last question. So we have to set the equation to 0 and solve. -2 bracket open x plus 4 bracket close bracket open x plus 1 bracket close bracket open x minus 2 bracket close is equals to 0. We solve it and we get x is equals to -4 and x is equals to -1 and x is equals to 2. So to make a sign analysis chart, we have to use the critical values found in step 2 and divide the number line into sections. So we divide the number line at -4, -1, and 2. And then in the step 4, we pick the signs by solving them. In this case, we can choose x is equals to -5, which results in plus 56. X is equals to -2, which results in -16. X is equals to 0, which results in plus 16, and x is equals to 3, which results in -56. So yeah, we just put the signs there, and then the step 5 would be use the sign analysis chart to determine which section satisfies the inequality. So in this case, we have greater than 0, so we can all we want all the positive sections. So step 6 would be to use the interval notations to write the final answer. All right. So the final answer would be negative infinity, comma -4, joined by -1, comma 2. All right. We'll move to the next. Solving nonlinear inequalities. So rewrite the inequality so that there is a 0 on the right side. First step is this. Second step would be find all the linear factors of the function. Third step would be to find the critical values. So we have to set each linear function to 0 and solve for x. Then step 4 would be to determine the sign of the function in the interval form by the critical values. And then the step 5 would be the solution will be those intervals in which the function has the correct sign satisfying the inequality. So we have an example next. So quadratic inequalities is type of nonlinear inequality. So it contains in both x square and x. For example, x square plus x minus 6 is is greater than equal to 0. Factorizing gives us x plus 3, x minus 2 greater than 0, greater than equal to 0. So it is x square plus x negative 6 is equal to 0 when x plus 3 is equals to 0 gives x is equals to minus 3, and x minus 2 is equals to 0 gives x is equals to 2. So we put the in the on the inequalities and minus 3 and 2. And the final solution said we can substitute a value from each of the each of the following three regions. So the region 1, 2, and 3. So into the original inequality, x squared plus x minus 6 is small than equal to is greater than equal to 0 when x is equals to minus 4. So minus 4 squared plus minus 4 minus 6 is greater than 0, greater than equal to 0. So 4 square gives us 16 plus 4 we change it to minus 4. Minus 6 is it gives us greater than equal to 0. So 6 is only left. 6 is greater than equal to 0. So this is true, and so the values in region 1 satisfy the inequality. Now we have solving nonlinear inequalities graphically. As I've told you, in the linear inequalities, we can use the graphing calculator in the exam. So we will use the graphing calculator here, and we'll get x squared minus 3x minus 4 greater than 0 will get us x is smaller than negative 1 on one side, and x is greater than 4 on the other side. And I've done this on Desmos, not on the graphing calculator, but on the graphing calculator we'll get a bit similar. Yeah. Now we'll be using the factor table to solve the inequalities. So solving the inequalities is equals to x minus 4, x minus 3, x plus 3 is greater than equal to 0. So we'll put it like this: fx is equals to x minus 4, x minus 3, x plus 3 is greater than equal to 0. So the solutions are in the intervals where fx is greater than equal to 0. So fx is equals to 0, x minus 4, x minus 3, x plus 3 is equals to 0. So x would be x is equals to 4, x is equals to 3, and x is equals to minus 3. So these numbers divide the number line into 4 regions. So we can factor it like this: x minus 4. We put it in the equation and we get x is smaller than minus 3. We put this in the equation and get a negative sign. And we put x minus 3 in the equation of x is greater than smaller than minus 3. We get a negative sign. We put x plus 3 and x is equal to smaller than minus 3. We get a negative sign. And we put it like this: fx is equals to x small than equal to smaller than minus 3, we get negative sign again. And then we continue this in minus 3 greater minus 3 smaller than x smaller than 3, and 3 smaller than x smaller than 4, and x greater than 4. And you can see where there's a bit of positive sign, we can get positive sign when we put x plus 3 and minus 3 smaller than x smaller than 3, we get a negative, we get a positive sign. And we when use fx is equals to minus 3 smaller than x smaller than 3, we get a positive sign again. And in x minus 4, x minus 3, x plus 3, and fx, if we put all of them in the positive value of x is equals to greater than x greater than 4, we get all the positive values. So fx is greater than equal to 0 when minus 3 is smaller than x smaller than 3, and x is greater than 4. This is the summary. Now we have the leading coefficient formula for a polynomial function of a degree n when n is a positive integer for the n difference are equal. They have the same sign as the leading coefficient, and the value of the n difference is equal to a dot n. So the leading coefficient will be nth difference is equal to a dot n. A is equals to nth difference upon n. So nth difference is the value of the constant in the last column of the table. A is the constant, A is the leading coefficient LC, and n is the degree of the polynomial function. And this n is equals to 1 multiplied by 2 into 3 into 4 and so on and continues. So the finite differences. The finite difference, we can determine the degree of a polynomial function by investigating the graph. Another way, more precise, is examining the table of values. So the first differences are constant. The relation is linear, the degree is 1. So in a way, it's like x is equals to 1, 2, 3, 4, 5, y is equals to 3, 5, 7, 9, 11. So we subtract y, second y minus the first one. So 5 minus 3 makes it 2. 7 minus 5 makes it 2. 9 minus 7 makes it 2. 11 minus 9 makes it 2. So we have to find where the degree is 1, and not only 1, the degree can be larger. We just have to follow where the have a uniformity. The numbers find a uniformity and are in a straight line. Like here we have 2, 2, 2, 4, 2. So there we can stop. And if we had 2, 2, 5, 2, then we had to continue. So that's obviously not an example which I gave. But if it was not an even number or a standard uniform number, so we will have to continue. We have examples in the next slide. Table 1 gives us n is equals to 1, sign of the leading coefficient is positive. So we put it in the formula as a is equals to nth difference upon n. So it would be 2 over 1, and it would make 2. And just like this, we have third difference, we have second difference, and fourth difference as well. So we have third difference in it. We have x is minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. And y is equals to minus 36, minus 12, minus 2, 0, 0, 4, 18, 48. And so the first difference is like minus 12 minus 36, which gives us 24, minus 2 minus 12 gives us 10, 0 minus minus 2 gives us 2, 0 minus 0, 0, 4 minus 0, 4, 18 minus 4, 14, 48 minus 18 gives us 30, and so on. Till the third difference where we have minus 8 minus 14, which is 6. We have minus 2 minus 8, which gives us 6 again. 4 minus 2, 6. 10 minus 4, 6. 16 minus 10, 6. So here we have uniformity in the third difference as well, so we'll stop here. And so table 3, n is equals to 3, sign of the leading coefficient is positive. We just put it in the formula again, 6 over 3 is equals to 6 over 1, 2, 3 is equals to 1. Fourth difference is the same. We have now we don't have solved ones. We have x is minus 2, minus 1, 0, 1, 2, 3, 4, 5. Y is minus 54, minus 8, 0, 6, 22, 36, 12, minus 1, 1, 0. So the first difference would be minus 8, minus 54 would give us 46, and so on. We continue till minus 110, minus 12, which gives us minus 122. Because minus minus makes a plus, and we continue till the fourth difference where we have 22, where we have 12 minus 16, so it gives us minus 24. Then we have minus 12, which gives us 20 minus 24 again, minus 36 minus 12 minus 24, and minus 16 minus 12 minus 36 gives us 24 again. So yeah, we have found the uniformity here in the fourth difference as well. So we'll put it in the formula again. We have a minus 24 upon 4. So this number 4 just in the remainder is the difference, line of difference where we find the uniformity. So negative 24 upon 4 in the last slide, we found it in the third difference. So 6 over 3 minus 24 upon 4. So it gives us minus 24 upon 1, 2, 3, 4. 1 multiplied by 2 multiplied by 3 multiplied by 4, which is equals to minus 1. Now we use the finite differences to determine the degree of a polynomial as well as the value of and the sign of the leading coefficient. So finite differences are calculated from the table of the values in which the x coordinates are evenly spaced. The first differences are found by subtracting consecutive y coordinates, and second differences are found by subtracting consecutive first differences, and so on. So the first differences are constant, the relation is linear. The second difference, the constant, is quartic, just like we have studied in the graph. and yeah, we have studied in the graph. So the third difference would be cubic, and the fourth difference is quartic. Otherwise, the region is higher degree. And thank you, all of you. We hope you understand the topic very well. I hope you guys can ask us anytime. You guys can, if you don't understand anything, we have our links. Our website is there. We have our media links as well. You can just type an email to us and we'll just help you. We'll be more than happy to help you. Thank you all. It was a pleasure teaching you all. Thank you.